Okay, team. In this lesson, we're going to apply our sign charts and our knowledge of derivatives back to our particle motion problems. It's been a little while since we've seen one of these, so I've given you some hints here on the right-hand side. Make sure you get this in your notes if you don't have a good reference in this already. Particularly, it's really important to know that the derivative of position is velocity. The derivative of velocity is acceleration. And then these facts about the particle is moving right when velocity is positive, left when velocity is negative, and is at rest when velocity is zero. Those are really important facts to analyze in problems like this. If you think about it too, you can see the connection between our work with sign charts and these problems pretty clearly. Okay, let's jump into the example that we're given here. This is an easier one. We'll tackle a harder one here in a second. So we want to know all of the intervals when the acceleration of the particle is positive. Okay, so let's see, we have x of t. We're going to take the derivative. We want acceleration, so we're going to take the derivative twice. So my first derivative is v of t, and I'm just going to use power rule, so that's 5t to the fourth minus 20t to the third. And then a of t, this should be very easy to you at this point, is 20t to the third minus 60t squared. Okay, so there is my derivative. We want to know when the acceleration is positive. Okay, so let's see. We're going to make a sign chart. We're going to start by finding the zero. So I'm going to set acceleration equal to 0. And I'm going to factor this. So I'm going to look for a common factor. And notice 20 is a factor of each term. And t squared is a factor of each term. So 20t squared. And then t minus 3 is my... So now I'm going to draw a sign chart. And let's see, my zeros are t equals 0 for that first term, t equals positive 3. Oops. So 0 is here, 3 is over here somewhere. And the nice part about these particle motion problems is you can ignore the left-hand side. Anything to the left of the 0 is not included because remember, t is time. So time is not going to be negative in this case, so this is not in the domain. So we don't have to even check that. But here we should plug in a t. I'm going to use t equals 1 for this interval. And I get positive 20 and then negative 2. So that is a negative interval. And then I'm going to use, I guess, t equals 4 here. I'm going to get 16 times 20, which is some bigger number. I don't really care what it is, but it's going to be a positive number. And then 4 minus 3 is also going to be a positive number. This interval is going to be positive as well. Okay. So let's go back up to the question. It's been a second. Determine all the intervals where acceleration of the particle is positive. Well, looks like from 3 to infinity. So a of t is bigger than 0 on 3 to infinity. Conclusion, this is what we would put in on Delta Math. Okay, so like I said, that's an easier one. Pause for a second and make sure you followed that. And then we're going to move on. So notice, I just use my acceleration function in this case for my sign chart because the question is asking me whether acceleration is positive or where acceleration is positive. So that's what I'm going to use. So we don't have to concern ourselves so much about increasing and decreasing for these lessons because each derivative function already has a name, right? So if it asks me about velocity, I use velocity for my sign chart. If it asks me about acceleration, I use acceleration. Okay, here is the harder type of problem you can run into. This one is harder because it asks me now about speed. Okay, so remember, speed is the absolute value of velocity. So velocity without the sign. And that absolute value makes our conclusions about speed a little more complicated. So I threw these at you before a little bit earlier in the year. We're going to really use these now. We're going to leverage our sign charts to figure out questions like this. So speed is increasing, we say, when velocity and acceleration have the same signs. So you can think of acceleration as kind of pushing velocity in the same direction it's going. Speed is decreasing when acceleration and velocity have the opposite signs. So positive, negative, or negative, positive. You can think of acceleration as kind of pushing against velocity. I always think of like riding my bike into the wind for that case. Okay, so that's what we're checking now. In this case, we want to find intervals where speed is decreasing. So speed is decreasing. We want to say, so V of t and A of t have opposite signs. Okay. So let's pay attention to what we're given. We have V of t already. Okay. I could give you this problem and give you x of t, give you the position function. And it'd be the same problem really, you just have to take an extra derivative, right? So pay attention to what you're given. So here we have V of t. So V of t, I'm just going to rewrite it so it's clear that I have it. I'm going to leave a little bit of space for some more work, and then I'm going to find A of t down here. A of t is going to be the derivative of V of t, so power rule. Negative 18t plus 18. Okay, so that's acceleration. Now, I'm going to factor, right? So I'm going to factor out a negative 9. I get t squared minus 2t plus 1. I'm going to factor again. And I get negative 9. Then t minus 1 squared. Right? So t minus 1 times t minus 1 will give me negative 2 and then plus 1. So that's my factored form of v. And I'm setting that equal to 0. So v of t equal to 0 equal to that. Okay. The solution to this is obviously t equals 1, right? And my sign chart then would just have one x-intercept, or one t-intercept, I should say, at t equals 1. And then we just have to check two values. So I'm going to plug in 0 on the left. And careful here. So 0 minus 1 is negative 1. And then I'm going to PEMDAS, right? So squared is next. So negative 1 squared is positive 1. Times negative 9 is negative 9, right? So this region is negative. Okay, so if you ignore this square, you're going to get this one wrong. To the right of t equals 1, a little bit easier, so I'm going to do 2. So 2 minus 1 is 1. Squared is still 1. Times negative 9 is also negative. Okay, so these regions are both negative. Then I'm going to make a sign chart for acceleration. Same thing. It's helpful as you do your work to line these up. It makes it easy to see. Okay, so let's make sure our 0 is the same first, but it will be, right? So I can factor this if I really want to, or I could just set it equal to 0 and solve. It's the same result. So I'm going to factor out my negative 18 and get t minus 1. Then I get t equals 1 is my 0. So I'm setting this equal to 0, right? And t equals 1 here. Okay. So I have my sign charts lined up. I'm going to check a point for acceleration. So I'm going to plug in 0 here. 0 minus 1 is negative 1 times negative 18 is positive. Right? Negative 1 times negative 18 is positive. Then on the right here, I'm going to plug in 2. 2 minus 1 is positive 1 times the negative 18 is negative. Okay, now we have enough information to answer a question. Determine all the intervals when the speed of the particle is decreasing. So V of t and A of t have opposite signs. Okay, well, it's here, right? So negative, positive, opposite signs. So that looks to be from negative infinity. Well, we should say 0, right? Because we don't want negative time. So we'll say from 0 to 1. Speed is decreasing. That's it. These questions dealing with speed are the hardest ones. Give them your best effort here. I think lining up the sign charts is key.